tried it last night. So it's got to be a manual focus. They don't have a remote on here, and I brought my remote, and it doesn't work with it. So clip over there will try to readjust the focus. Everything, I have most of everything written on slides, and I will do some sketches and some drawings over here. I'm trying to integrate alchemy and some basics about chemistry and some work that they've done in quantum physics, you know, where they talk about some of the nuclear structure, because our scientists have such sophisticated analytical equipment now. They're discovering a lot of things. If you kind of look at it one viewpoint, you can bounce it back and maybe tie in what the alchemy is going. I have a couple theories about what's going on in the nuclear realm and how we're really causing these changes to affect in the chemicals, how we're really manipulating the molecular structures by working on what they might call subatomic particles, the tiny little nucleons and the quarks and all these bosons, all these crazy names. You don't have to know what they are. You know, there's little tiny particles that the scientists are finding out, nuclear physicists. And I'm finding the only people I can really talk to when I've done work in alchemy and trying to do stuff at the grad level, the chemists don't want to listen to you. And it's very difficult to get anything through a school system if it's not through like a grant system. And when I did things in the home lab, they didn't want to analyze a lot of things because they were afraid of what I was doing. And they want everything under their noses, and they want to know every stepwise thing. And you know, there's things that I came up that shouldn't have occurred. You know, I said, this can't happen. So they kind of freak out about that kind of stuff. So it's good, because it lets me know, you know, what they're not aware of and the way they see things. But that's a rough way to learn it. So I'm going to try to explain it the way I see things, tying things together with electromagnetics and how our three-dimensional world is created and how everything is really electrical in nature. Everything is really energy. It's just only pure energy. So we're going to go through some basics of electromagnetics to see how the three-dimensional world was created. I'm trying to tie this all into alchemy, so I took a lot of, I'm going to have to take little jumps sometimes. We'll give them some little bit of analysis, the way spectrometers work, you know, the way chemists see things, the way physicists see and measure things, and try to bring it all into what we're doing in alchemy. Then I prepared a lot of different things, different compounds, so I brought samples of everything that we're going to see on the slides. I started levitating. Well, it went volatile. It says volatile sulfur. I guess it's not kidding. So I'll pass around these things, and I have a couple interesting things you might want to play with and see and try and feel. I brought some paper towels because I have some compounds where I've got this fatty substance that come over in distillates. So we'll start the show and see what's going on, and I'll try to talk slow. If I go too fast, let me know, because we got a lot of time. First of all, I'm going to cover, these are just a couple handy reference books that I found are really useful. Handbook of Chemistry and Physics. It's a good source to look for inorganic and organic compounds if you know what you're working with. You could find like solubilities and at what temperatures things will dissolve in, like potassium carbonate, how much water they might hold. Sometimes it's kind of neat to look like potassium carbonate. You'll see how much water of hydration, how much water it'll hold. You see like .7H2O, you know, it'll hold 7 times water molecules. So it's kind of a neat thing to know. Then you know if things are toxic, and what takes them off. You know, what dissolves them. So if you spill something on yourself, you can, you know, find something to get it off before you go, as long as it's not cyanide. I put on in a reference list. I have it as number 1. I just says you can try to use Bookstore. The new ones are about $95 when you get them new. I think it's a 75th edition, the latest one or something. It'll come up. You'll see it on one of the slides. It's coming out just now. So I just went to a used bookstore and got one for about $20. Because like I said, we're doing work in alchemy, and I find that sometimes the older books are better. Yes.
Is the edition important? 56th?
No, that edition number is important. That's just what
The older the better, or the older the cheaper?
Yeah, the older the cheaper. And since most of the stuff we're into,
for about $5.
yeah, 5, 10, 15 bucks depending on the place. The newer you get, the more expensive it costs. And basically, we're doing most of this stuff in inorganics. Those tables haven't been updated a whole bunch. Most of all chemistry went to organic in the last 25 or 30 years. And you can hardly find any places that really are good in inorganic chemistry, metallo-organic chemistry. And the stuff they do is really, really weird. They do extremely high pressures and real low temperatures and liquid ammonia and stuff like that. Things we don't want to work with. Another handy Okay, speak. This isn't moving. Oh, I know why. You have to plug it in. Yeah, here it is. It helps.
I can't hear very good.
You can't? Oh, because of motor noise? What?
Maybe partly, yes, but how about the people back there? Can they hear good?
Can you hear back here at all?
I can hear you well.
Okay. What? No, he's next to the blower on this thing.
That'll mask the sound.
Yeah. You want to move forward, Cliff, or something, or we
I
could?
can't do the machine.
Well, we shove it back. Now I have my calibrated newspaper to hold it just the right height.
That's chemical rubber, right?
Yeah, Chemical Rubber Company. It used to be called the Chemical Rubber Company, but the book became so popular they just call it CRC Press now. I think they're in Boca Raton, Florida. Same place IBM is. Let's see. Ah, there we go. Here's another handy index, and that's blurry too, isn't it? I love these new machines with the autofocus, auto-unfocus. It's called the Merck Index. The Merck Index, they have a special on it for this year. There's a little flyer that comes in some of the chemical brochures, but it's like, oh, here it is. Centennial edition, $35. And it's like a kind of like a simulated leather-bound type thing. And I have the address there. You could either get a copy of this flyer or they have an 800 number. What's nice about the Merck Index is they have all the essential oils in there. And I have a lot of the chemical and molecular structures, and they'll tell you what they're soluble in and give you some of the features and some of the breakdowns of the ketones. Or yes?
There's a problem with the Merck Index. They changed everything around on there. There are drugs in there, not drugs. There are offshoots and derivatives from procedural aspects. And what they did, it said psychic stimulant, which it used to say before the 1960s.
Uh-huh.
They took it and eradicated all that, but there were some to a biochemical interrelationship with the internal workings of the body that these compounds would manifest. And they took all that out of there, so they didn't want people to know about that, so they eradicated it. Luckily, I had the version before they did that.
I have an older version of it too.
Yeah,
But I thought the newer version has like MDMA in there, where the older versions didn't.
right.
Ecstasy. That supposedly wonderful compound. Which is interesting. We'll get into a book written by Dr. Alexander Shulgin called PCAL, Phenylethylamines I Have Known and Loved. And he was a Berkeley chemist who broke off from the tradition and just manufactured and synthesized hallucinogenics, psychotomimetics they call them. He became a psychopharmacologist, went back to medical school. But the interesting thing about reading him, and he'd try all these chemicals, and they had a tasting group of a lot of clinical psychologists and people who are into meditation, and they had very high IQs, but they're trying to reach spiritual levels here. I call them +1, +2, +3, and +4. +4 is seeing the face of God. But he was working at it from a spiritual point of view, even though the CIA was using a lot of his research. But I'm going to get into the aspect of interesting patterns I saw, patterns that were showing up as he altered the chemical structures. And I'm going to try to tie this into what's happening to some of the chemical structures and how we're affecting some of these things. Another good blurry one. We need to shove it over too a little bit.
Yeah, turn it a little because
I mean,
that side is further, that side.
yeah, you'll have to move the machine. Could you?
The screen has to be turned. Hold you right there. Do this.
No, this is off the edge though.
I didn't mean that.
Oh, okay. Oh, you want this because we're not perpendicular to the projector. Is that better? It's still blurry. Yeah, this is an interesting. They're kind of there. Well, it's an interesting periodic table of the elements. It's large. It's like Reference number 3 I found in a place called Miners Incorporated in Riggins, Idaho. I saw this at school a number of years ago that they have all elements, if you see, they're all as they are in the real metal states. And if you could notice real close, they're all silver looking. Every one looks silver except for some of the oxides. These are radioactive and they're oxides. And these are the gases, your noble gases. But I remember seeing this, and I went back into it in the dream one night, and all of a sudden I realized that the only ones that were gold color is copper and gold, and we have phosphorus. And then sulfur. But everything else is silver looking. It always kind of puzzled me why everything looks silver, because it's really saying that most of creation, this is where we come out of this, and everything we know comes out of this. Silver's the moon, so basically everything's very feminine and lunar and receptive, so we really see where the Mother Earth comes from. It reflects itself in the way the metallic elements look. And they all actually would be silverish more, except for the few with the gold and the copper column. Even with radioactive elements, but they only can really get them as oxides because they're too unstable in the metals. Plus they're highly radioactive as a free metal. So this is an interesting chart because it kind of just showed me the aspect of everything being very silverish, very lunar, very feminine. Most of everything we're created from. So that source comes from Miners Incorporated. It took me a real long time to find this because it was made by Time Life and the British Royal Chemistry Society. It was made in 1980s. And this company bought them all out. They used to sell them at American Chemical Society meetings, but then they stopped. And this company bought them all out, so the last known sources are from them. This is a little handy trick when I was calcining herbs that I just thought I'd bring up. It's under my tidbits of information. The chemists sometimes talked about a reverberatory furnace and a normal furnace. So a reverberatory furnace, I found out, was a furnace where the fire came from on top. What we're getting more is a reduction instead of an oxidation. Oxidation, we're adding oxygen, so we're getting more oxides. Reduction, everything's being consumed because the flame's there. So we get a little change in the chemical compound. And some of the metals preferably work better when they're worked the reducing flame. That's kind of like when they're making the bosmas that Junius talked about, where they seal them up in a crucible and put them in the fire. They couldn't access oxygen anymore. So it was more of a reduction. Because all the oxygen that was inside there would be tied up right away, and then what was left. So you get different reactions. I found when I was calcining some of the herbs, some of them would be a little difficult to work with, especially I was working with ones from the sea, like bladderwrack and some of the seaweeds. And I found this is the only way I could really get them to calcine. And I noticed as I was calcining them this way, that I was getting them to dissolve better when I threw them back into the basic tincture. So I was getting better solution. So whatever is going on there, the salts became more soluble. Now my salts are almost, when I take the tincture after putting them back in the alcohol solution, there's very little salt left to filter out. It almost all goes into solution. So it might be a kind of neat little trick to try. But that was when I realized the reverberatory furnace, the top heated flame, gives you different products. You get a reduction product instead of an oxidation product. So that's an interesting thing to try and play around with. I just kind of control the flame. I just have it kind of licking over it. That's like a Fisher burner, which is like the Mecher burner. And you can make the flame real strong, but you can also adjust it. I just adjust the gassing so it just kind of licks over it. So you can spread a real wide flame to lick over it. I've done it with Bunsen burners too. This one just was a bigger picture. So I left it up there so you can see it like that. One thing also I was going to mention while I'm talking a little bit about herbs. We talked yesterday, Marcus brought up about the Krummenacher method, Biot's method. And I played with that somewhat because I started teaching some beginning classes in alchemy. So I wanted to try everything and show everything to the people. So I was kind of interested in his project. And he gets complicated after a point, after he has the sugars, because then he wants to bring the alcohol up to 22%. So it might have turned a lot of people off from trying that method because there's a lot of calculations. But I just found I used the first calculation where you just did the weight, dry, and wet. But I found a trick that if you add the sugars, now we had a little debate about whether to add the sugars or not. But I did a lot of winemaking previous to that, 20-some years ago, before as I started getting involved in alchemy. And I got the hydrometers and the stuff to measure the acids. And I found sometimes you can bring the acid up a little bit and get a better fermentation, but if you ferment slower, you don't get the side products, the fusel alcohols, the amyl alcohols and the butyl alcohols. You don't get those forms. Those are the ones that give you the headaches and the cheap wine when they don't age them long enough. Because normally when you age the wine in the cask, the wood, the proper wooden cask, will absorb those alcohols and will diffuse, and the ethanol stays in there. So that's why you get the better wines that have been aged a long time. But I also found that if you ferment slower, and add your sugar in stages, a little bit at a time, dissolve it in water, make like a thick syrup, and just add a little bit of the sugar and keep your fermentation going slow. You almost get a pure ethanol, and you won't get any of these side products. But I also found the Biot's method, if you took the sugar that he gave there and took 3 times that amount, it tripled it. If you take 3 times that amount and add that very slowly in stages, when you do your first distillation, you'll get 25% alcohol, and then you're done. So you don't have to go through those calculations and add external alcohol. I always kind of felt, I've been getting to the part where I've kind of believed that whatever nature puts into a product as it created it, we should not tamper with it right away. Because all the life forces are in there, all the little trace elements. That's where chemistry separated. Chemistry started purifying everything, making pure products out of everything. And sometimes, since the alchemists didn't have analytical equipment, or some of these little catalytic, the side products that actually got into there, and they didn't describe the process real good because they just dug up an ore. Yes.
Could you just slow down the speed a little bit?
Slow.
For your delivery.
Okay. Since they couldn't analyze things real well, some of these side chemicals got into there. What the chemists would call impurities nowadays. But a lot of times that was actually the key to what triggered it off. And it also dawned on me as I read through all the processes, and I've been working on these things for 20-some years, that everyone seems to be talking about a different method. And there's different ways of making the stone, especially the metallic stone. And I think what happened is the alchemists got to the point where they tuned into the particular mineral they're working with and became part of it. And they developed the processes that spoke to them and to tell them how to work it. That's why this guy, Valentine will go one method, we'll see Philates will use another method, and somebody else will use another method, because they tuned into that particular one with all the side products and maybe the other metals that were there, and it told them how to treat it, how to deal with it. So we're reading everybody's lab notes. And we're trying to put all these little pieces together and then try to come up with a process using part of this, part of this, part of that. I don't think it really works. You really got to become one with it and tuned into it, and it'll tell you. It'll teach you. That's where it says imitate nature. And try to find out what it's doing, and it'll speak to you. It'll tell you what to do with it. So, the fermentation, I think, gives you better side products. That's my feelings. And the life force, I believe, that's in the living plant will get transferred over into the mercury, into the alcohol. And we're going to talk about coming up real soon about water. I think the whole key to this whole process is in water. And that's really the prima materia, the first matter. So that energy is being transferred into the product as it dies. In a plant, if you take a fresh plant, we have 2 mercuries in everything. In a fresh plant, if we pluck it right away, there's a mercury there that leaves as it dries. Then there's a second mercury that's bound to the cellular structure. The same thing is like in our bodies. There's a mercury or a life force in our blood. And as soon as we die, that'll leave, but then there's still a mercury force, cellular mercury, that's left in the body that we can still do extractions on the dead body. That's why in a lot of the old rituals, they slice something by its neck and drink its blood immediately. They get that big rush from the chi that was in the blood, the living blood, which it leaves in 15 minutes. And our blood banks show us this by the fact that they have to take constantly transfusions from living people to transfuse, because if you take blood from a dead person, it's useless. Something gets left. Now, chemically, there's a few changes that go on, but not that many significant ones. But science doesn't want to admit there's a life force. We have this in our fact of our blood transfusions. We have to constantly get fresh living blood from a living person to transfuse that. If you give dead blood from a dead person, the person will die. But they can't measure that difference in there. And it only lasts about 3-4 weeks, refrigerated, because the cold. Yes.
Brought up a superior point, because I just came back from Michigan with there's a lecture series by one of the individuals, and I asked him to come over here and join the Alchemists, and he's taking a beginner course in alchemy, and all his research has been on colloidal water, and then the electromagnetic aspects of it, and the surge power of it when it internalizes within the body. And some of the findings that all this research has come up with, the high energy that comes forth from colloidal water is just massive. It was just mind-boggling series.
Mm-hmm.
So it goes along in the line with what water you really choose.
Right, right. Well, we'll get back to some of the stuff Marcus did too, and some of the effects. This is a little handy piece of equipment that I came up with when I was doing a lot of distillations. I used to have flasks made with little taps on the side so I can draw out a vacuum. So I had a glass blower make this little thing up for me. It allows you to take anything with the 2440 joint and make it into a vacuum adapter. I just stuck it into a flask like this, so now you just take any, instead of having a tap on the side like I'd had before and they break off, you just stick it into any flask, just put your connector into here, and you can pull up a vacuum, and this thing will go into any kind of piece of equipment. It's a kind of handy little thing. Marcus might think about getting something like that added to it. So you can convert anything to a vacuum adapter system. You can just shut it off. On that Biot's method too, incidentally, he talks about distillation under a vacuum at like 135 millibars. And that comes out to about 4 inches of mercury. It's not very much. I found that his vacuum that you can really hold is by putting a little tube in there, sucking it at one time, shut it off, and there's 4 inches of mercury. So you don't even need a pump. It's a very mild vacuum because there's a vapor pressure boiling alcohol gets up there, so you can't hold a very high vacuum anyway. And the stuff will just boil over. So it's 135 millibars is about one good suck out of the thing. Yes, Marcus?
It'd be cheaper not to have a valve, but just put a piece of tubing and pinch clamp on to draw vacuum.
Yeah, I tried that too, but then I found, depending on the tubing, that sometimes I couldn't pinch it off real good, and it was a pain in the butt. If you're heating up a system and you want to put a vacuum, you have to keep drawing a vacuum. You bring a system to boiling because the vacuum will keep dropping until it reaches the boiling point, and you get equilibrium in the vapor pressures. Yeah, it costs a little more, but I never broke one of these yet. The ones on the side, I bang them and they snap off. And so I had like 5 of them made, but I found I've only used 2 of them, and I've been able to do everything pretty much with them. So with the Teflon, you don't have to grease it. It only cost me about $25 or something like that. Yes, Art?
Some of the newer people may be intimidated by the thought of vacuum. Doing some pricey vacuum comes in hundreds of dollars. But there's a little hand gadget that's about $30, $35, and you can produce a vacuum which is adequate for most circumstances.
Yeah, you can buy those from Sears.
Auto parts. The auto parts.
And they have those water aspirators you can hook up to your sink faucet. It's a little straight tube and it goes down and it pulls a good vacuum, pretty good vacuum. Yes?
Yeah, Beyond reverses numbers on its vacuum too. If you simply pull 4 inches of vacuum and think you're going to distill that at 33 degrees C, you got another thing coming. It will never happen. In fact, you got to pull, he calculated out, realized that he got his numbers reversed. It's 30 inches of vacuum he's pulling, he's at 33 degrees C.
Oh, okay.
So, I mean, you guys, you need to know about, I've done this whole process.
Mm-hmm.
You need to know that those numbers are reversed. It's not 4 inches he's talking about. It's 4 inches from the absolute even.
Oh, okay. So he wanted 135 millibars left? Oh, that's really high vacuum.
Yeah, yeah.
Well, I've done it just with the lower amount and I've still got a good product. I get the higher the vacuum you get, you'll get a better distillation, a smoother one, but it's...
His big interest is to get it down to where you can distill at 33C.
Yeah.
And you've got to really pull a vacuum to get that.
Yeah, then you have to have really tight joints. Another little handy thing, if people that might be working with the antimony work, I found this little book, Crucible Furnace, David Gingery. What he does, I was going to put this in the stone, but I just can never get the timings right with them. What he does, he makes it, your furnace like LPN shows, he makes a little frame out of angle iron. And so he makes a place where it splits in half, because that problem I noticed when you're playing, you always stick a crucible down there and you have always the chance of the flame shooting up into your face. But he just took the furnace in half, and it looks like we could basically take the furnaces we have, cut them in half, and just put a little frame around there. And it shows how to make a little angle iron thing where you got a lever and the middle of the furnace lifts up. You can just put your crucible right there and you just close the thing down. So I thought that was kind of a handy thing. We could even convert the old furnace just by building its frame. And that's Lindsay Publications is reference number 4. They have a lot of different types of furnaces there, real cheap books, around $8, $9 range. With this guy, Dave Gingery, he's a real handy mechanic, and he tells you how to build all kinds of stuff from scratch. He has gas-fired, he has all kinds of flame-fired, he has electric furnaces, and he tells you where to get all the parts, and step-by-step process how to do it. So it's real kind of neat, interesting stuff. They also have a lot of neat books on like Tesla and other kind of things, building all kinds of mechanical apparatus, and they have ones on electrical apparatus. It says Lindsay Publications. Now I'm going to talk a little bit about water, because it's been my impression that water is really the prima materia, the first matter. And it came about when I was at this class last year, what John was talking about, and I started thinking about it a lot, and about the previous work I've done, and some of the other work I've done, and a lot of things started coming together. The sun just rise.
Must be windy out there.
Oh yeah. So the rainwater and the dew water, I did a lot of work with it the year before. I captured the dew water right in the springtime. Took about 15 pounds of potassium carbonate and had glass Pyrex dishes that I was putting out at night and then bring them in the morning and then collecting the dew water. And then I made a distillation apparatus, and I was taking some measurements on it and then using the dew water in experiments. Oh, and then when we had rains in LA, which don't happen very often, it happens in the springtime, I let the good rains come down, then I had plastic sheeting on the roof, so I let it rain good for an hour or two to blow the dirt out. And I collected the rainwater and filtered it, and I was doing rainwater distillations. And the last apparatus we saw in the stone, well, was an apparatus that I built about a year and a half ago too. Well, what I'm going to talk about on the water, I'm trying to find where the energy might be stored in the water and why there's different kinds of water. And this is the way physicists see the water molecule. Here we have H2O. And these are the fields of energy. They call them the van der Waals envelopes. The old model of the atom, we were taught in early chemistry, we were just shown as the nucleus in the center, with the proton and the neutron and the electrons when travel in circles around it. Doesn't hold true anymore. The physicists, as they got more and more, they found out that they're actually in areas and little groupings, we'll call them like S shells or the P subshells. They actually cover an area, a band like this. And they're actually skittering all around through here. And there's some entities that were able to see this and said that the electrons actually are dancing in and out beautifully. Well, they found out they can't even guess where it's at. They have what they call probability and Heisenberg uncertainty. They're not really certain where it's at, so they know that they could tell you that a certain area probably could be somewhere in this area or just this area, but they can't really tell where because the electrons are moving all around. So they're finding out there's these big clouds that our energy is in. So we look on the water molecule, or H2O. Hydrogens actually come off at an angle. They show over here it's 104.5 degrees. There's a strange thing. They always wonder why they didn't come off straight, to the edges of the oxygen molecule. Then hydrogen peroxide is another exception where it has a twisted conformation. Those are the two weird exceptions, major exceptions, with a simple compound like this. And they still don't really know why. They get these strange angles, but I think the whole key to it is the oxygen molecule. So we know that in the yoga, the important thing is the pranayama exercises, the breath control. And in oxygen, they say, is the carrier of the life force, or the chi. That's why it's real important about the breath control, to try to learn to control the breath, and there's different patterns of doing different things, and they have different physiological effects on the body. So based on that, because the oxygen goes into our blood, and that carries our life force, I started studying the oxygen molecule in depth, and found out that I believe this is really the carrier. Since it's a carrier in the animal kingdom, it has to be a carrier in the other kingdoms too. So the oxygen molecule has some interesting properties. It has an interesting thing they call lone pairs. And these are some of the electrons in the shell that don't tie up in bonds, ionic or covalent bonds. And these are the lone pairs we have out here. And they stick out. When they put the oxygen, they usually put 2 dots. And there's 2 sets of these lone pair on the oxygen that won't tie up unless we create something like ozone, which is unstable. But I have a feeling that this lone pair area, these electrons, they'll pull together like this, they'll attract to each other. Here's 2 water molecules, and we see they're trying to, from the hydrogen, it's being pulled by the lone pair of the oxygen. And we'll see a bunch of these all tied together into like a big, nice, pretty lattice structure. You know, they'll form a big grid. But I got a feeling that some of these lone pairs, these electrons that are dangling out here, this is where the life force is being tied up. The chi or the life force is being pulled into these lone pair areas. Now it might be what we might call, we're not analyzing it so we don't see it, or it might be another dimension. As far as what we see as 3 and 4 dimensions. And because we know we have an etheric plane, or then the astral plane, or these different planes, but the etheric plane is most likely on that energy plane. That's why the chemists and the alchemists have had the problems, because the chemist analytical equipment and any kind of equipment, you have an idea, and you build a piece of equipment, and that piece of equipment will always keep telling you what you invented it to do, and that's all it's going to tell you to do. Unless it's real wideband, and then they start seeing other things, but they're usually, academia, I find, neglected. If they can't explain it, they don't want to be embarrassed, so they just kind of say, that's noise. That's fluctuation in the machine. We have to get a better one next year. So it's these noises and these little glitches that they throw out that I start looking at with real interest, because that's where everything seems to be. So in a water molecule, I think this is where our life force is being tied into these lone pairs. It's the only thing that's really sticking out there. Doesn't bind into anything. So it's kind of telling me that what the chemists don't use, that's what the alchemists are probably using. That's where all the tricks at. So it's kind of good to know science, because whatever they kind of reject is probably where all the answers really lie. This is the structure of ice with the water molecules. Now we can see the way they start forming the lattice structure, or the crystalline type structure, and the way the oxygens will bind to the hydrogens and the hydrogens bind to the oxygens, and they start arranging themselves into an order. There's also that interesting property of water. That's one of the materials that expands when it gets cold, and then ice floats in water, so the density even goes down, so it'll float on the water. So it's water floating on water. So these are kind of interesting properties of water, where again I feel is where the prima materia is, the life force. Even in the Emerald Tablet, they'll talk about the sun is the father. So we're talking about some kind of solar radiation coming off the sun. And then what the moon is the mother. And the air carries it in its belly. So they're talking about there's a reaction between the planets and the planet Earth, the feminine planet, Mother Earth, and the sun. There's some kind of solar radiation. There's all kinds of particles coming off it, and as physicists look further and further into it, keep finding new kinds of energies that are coming off the sun they're able to measure. Besides protons and all kinds of energy fields. And there seems to be a reaction with the upper atmosphere, where some of these particles get charged and trapped. I believe Bill was telling me that he just found that there's layering, that the temperature will start dropping. They found there's one of the layers where it goes up to about 500 C. goes very, very high temperature, then the temperature drops again very cold. So we have some boundary layer where there's a lot of chemical reactions could be occurring. 500 C, a lot of things could happen. So something is coming out the sun and is reflecting through the atmosphere, and it's getting trapped. What we have there, we have a lot of moisture. We have a lot of water. They say the air carries in this belly, so air is an element that flows. So we have a moisture up there, and somehow these energy particles are being trapped here. That's where we get the value of the rain, collecting the rainwater. Now this energy also comes down as a dew at nighttime. When I was studying the Qigong with some Chinese teachers, which is a Chinese medicine, a form of energy healing, we would do a lot of the Qi exercises at the crack of dawn and then at sunset. And the Chinese said they had the Qi energy changes states and comes down, becomes more available at the sunrise and your sunset. And I found that actually what happens is the Qi actually comes down at nighttime, and it stays around in the dew, which is probably why we sleep at night, because the thought patterns we hold, this matter gets attracted to us. It comes in at nighttime. It's in the dew, but it's also like a free type of protoplasm that can be seen and measured, and it comes into our bodies, and it heals them and rebuilds them. If we miss a lot of nighttime sleeping, we don't heal very well. I tend to stay up real late at night because I like that time. It's a real good time to think, and I probably get off in that energy matter. But there's twice a year that I'll just like fry, and I'll get like real weak and sick, and I think I'm dying. It happens every year. Tell my wife I'm dying again, I'm dying. And I just have to sleep a couple days. Because apparently I've been burning out that supply that I needed all the time. And I just have to have the trade-off, and I have to accumulate it back. I'll show some other pictures where some people have actually measured some of this. So the Qi force comes down at nighttime and is held in the dew. I found the dew water to be the most powerful as far as some of the work it'll do. And I find the rainwater to be second time as powerful. Now Hans mentioned something the other day about using a dehumidifier. And I always wondered about that method. I just never tried it. California is too dry now to use a dehumidifier. But did you try that?
I haven't.
Yeah. Now Bill Van Doren's going to set. Is Bill here today? Yeah. Bill is going to try to do some work of trying to collect some of the dew water, because he has a lot of it where he's living now.
Jack Glass did.
Jack Glass? He worked with the dehumidifier? Did he? Yeah, I always wondered about it. I was going to try to isolate it and take the ground off it. If I played with it, I'd remove the ground plug so I wouldn't touch electrical ground, so I wouldn't short energy out back to Earth. So I noticed about the dew water, when I watch it on a blade of grass, the little beads of water stick to the glass, the grass blade, and as soon as the first rays of sun come, you'll see a little bead trickling down. What happens is the Qi, the life force, goes up into the air, into the upper atmosphere, and then once it leaves the water just trickles back into the earth. So you have to catch it before the sun comes up. So I was doing a couple things when I was setting my dew water out. Since I go to bed so late, I don't like to get up early, or sometimes I go to bed when the sun is rising. I put it against the wall so the sun couldn't get it right away, so they give me an extra hour. So that's a tricky way to not letting the sun get on it. So here we see the crystal lattice structure of the water and ice, and we can see the way things can get trapped and bound in the molecules of the water. This is the way the water molecule ionizes. We get solvation by ionization. Here's your oxygen molecule. Here's the two hydrogens. You see they have partial charges, the plus and minus. So when we have something like sodium chloride, a salt, the oxygen will tend to pull that molecule and surround it, trap it. You see the water has a trapping function, and the negative charge. See the hydrogen, two hydrogen molecules here, will bind around it. It actually pulls it apart when it ionizes it, such as saltwater solution, sodium chloride. So we see your water that's really doing all the work. And I found out that in when we're dissolving metals with acids. Chemists have found out that it's really water that's doing the dissolving. The acid causes the water to disassociate, and it breaks up into H plus into OH minus. Now really we get 2H, because hydrogen will always want to be in H2, so it'll be 2H and 2OH minus. This is basically the way H2O will break up. And the strength that an acid will cause the water to dissociate is called a dissociation constant. They call it a pKa. And then for bases, they have a pKb. But this is the power of the acid that causes water to dissociate. And they found it's really the water, these molecules that are doing the attacking of the metal. So water is really doing the dissolving, not the acid. And then it binds with, like, if sulfuric acid, it'll bind with the sulfate ion, or if it's nitric acid, it will bind with the NO3, the nitrate ion. But water is really doing the shredding. They have a couple of things called a superacid that's made from antimony, pentafluoride or something. It's a very powerful, but it's like a pKa of 35 or something. It just dissolves anything, eats holes through anything. But it's really, we're seeing that the water molecules are really doing all of our work, just by its tendency. And we also, they always call water the universal dissolvent. Defining a second universal dissolvent that's almost as good as it is silica, silicon dioxide, molten glass will practically dissolve anything. That's one of the ways they're trying to store our plutonium now, is put into molten glass and just store the molten glass, because it breaks down very slowly, so it won't release the radiation. But as far as we're concerned, the water is a really important part we want to look at. This led me to, I was just driving around once, I was kind of told to pull over to this bookstore, and I was looking for a book that I couldn't find, but this magazine kind of struck me. And it was a Discover magazine. It's May 1993. And it was a work they're doing in a laboratory. I just flipped through it and opened to this page. And they're doing some work with some water that they got from a product from Germany. And what it was, it clicked right on. I don't know if everybody's familiar with the work of Wilhelm Reich, and his work at the Bions. Wilhelm Reich and his orgone energy, he took like sand, beach sand, and he heated it to incandescence, to flame, to white hot, and he would plunge it into a water based with a little bit of nutrients in there. And they got these things to start growing, and they will start glowing real bright, bluish. And they got to the point where they would give suntans to the people working them, or it would cause problems with the eyes. It was burning the skin tissue. The energy was so high. And this is where he came up with his orgone life energy force, and things like the function of the orgasm, where the life force is pulled through. But I always thought that was an interesting phenomenon. I built a couple of these orgone accumulators. And when I saw this article, I realized these people were playing with the same thing. They had some sand that was heated to incandescence, then it was plunged into a nutrient, and they found some enzymes started growing it, a type of bacteria. This is being done right now by this Dr. Adams at the University of Georgia. Life beyond boiling. At 212 degrees, water turns to steam, and proteins, the very stuff of life, turns to glass. But some canisters in Georgia creatures are just warming up. They found these enzymes sleep at room temperature. And as they took it to the boiling point of water, they become alive. And the hotter they got, the hotter they liked it. And the higher the pressure they put, the better they worked. They couldn't kill these things. They're unsterilizable. So it looked to me, it's the same thing that Reich was working on with his bions, and now the chemists are playing with it. It's somewhere between, they said it's not like a bacteria, it's somewhere between a bacteria and an enzyme. They're not really sure what it is. But I think this is the second thing where what's being hidden in the water. And it's all being done through water. So that you can't kill it at any temperature. It becomes alive at boiling. So we see the properties, the importance of a digestion, the heat. We have in the plant kingdom, we know we have enzymes in plants. those are the things that break the plant down and make them digestible. That's why I juice a lot of fresh carrots and celery and things like this. If you take a vegetable and juice it fresh, the enzymes to digest it are there, so you'll be able to digest it yourself. Once you boil it too hard, you'll kill the enzymes about 125 degrees. You'll start killing the enzymes in the plant, and a lot of your foods become undigestible. So steamed foods sometimes aren't very easy to digest. Like broccoli, and if I boil it real hard, it'll give me some gas, but if I drink it fresh, it doesn't bother me. Yes?
But it's interesting, a series that I listened to, gentleman, he's a physicist, from Qabalah, he said that years back, he said that later on, simulation working with computers, he said people don't know it right now, but the life force is in the silica, and it's an actual entity, another life existence that will come into being with computers and will actually manifest itself in due time.
Yeah, so that's further verification. As I talked about, as we have as above, so below, the plants have enzymes, and in the human, the animal kingdom, we're full of enzymes. They have the oxidase and the nitrase in the lungs. The oxidase takes the oxygen, the nitrase takes the nitrogen in, converts it, helps convert it to amino acids in our body. So the plant kingdom has enzymes. The animal kingdom has enzymes. They wouldn't leave one out of one kingdom, so the mineral kingdom must have enzymes too. And this is part that's tied into the whole life force. This is what I think was Reich was talking about with his bions. And we see that it's coming out of silica. That's why when I started working with the minerals, Friar Albertus would tell me sometimes, I asked him, could I work with this thing out of the lab? And he goes, yes, you could. He says, but eventually you'll have to use the ore if you want the real thing. So he was saying that it's good to do the lab, learn the lab technique on chemicals, and then when you know what you're doing, go get the real ore and work at that, because that's really where all the life force is in. You'll get products that look the same, but there'll be little shifts in them. Matter of fact, I find some of the shifts are pretty considerable. And you get different end products when you start using real live things. Now, we see that the silica containing the life force, we see we have a mineral, even though there's some dirt in it, it started to become, in my opinion, that the way nature created something, the way it created that mineral, everything that was necessary to create it as it is important. If we start separating things, we start acting like the chemists. Now, we can purify later on, but I think in your first stage, you should play with things just as they are. Because when you start tampering with them, you're pulling something off, if that wasn't necessary, it wouldn't be there. Nature isn't wasteful. Nature is like us. It's pretty lazy. It tries to always find the path of least resistance and the easiest way to do things. That's we kind of inherit that tendency too. So it doesn't do extra work when it doesn't have to. So it started becoming my opinion that whatever nature put there must be important to it. Otherwise it wouldn't put it there. It wouldn't be there. And we know things are different in different locations, which again shows us why the different alchemists came up with different processes for different substances, even though they might have been very similar, and they came up with a whole other way. We're trying to use some stuff that came out of Germany, and our process didn't work because we don't have that composition. So you got to learn to kind of develop that sensitivity and that feel for every compound is different. That's why when you start working with the plants and the herbs, you'll notice they calcine all differently. That kind of freaked me out. Calcination is kind of the pain in the butt thing we don't like to do. When you start calcining, you see some are very sensitive, and you have to calcine them very gently, especially if you separate the salt of the salt and the salt of the sulfur. Some of the salt of sulfurs will melt at very low temperature and very difficult to calcine. And some you can just hit with a big blast, and it sits there and glows and is perfectly happy. Other ones will fuse at very low temperature. So working with the plants, it kind of taught you that every plant is different in its nature. And the salts that come out of it, well, the chemist says it should be potassium carbonate, potassium hydroxide. It can't be just that. There has to be a lot of other things because they're acting differently. They're acting a little differently. So working with the plants is a good introduction to learning how to, before you start working with the metals, because they get more expensive and you have more dangerous compounds. Don't expose yourself to the danger, develop the technique, and once you learn that sensitivity with the animal kingdom, the plant kingdom, which is why you taught the plants first, then you'll have that sensitivity, so when you start going to the metals, you'll already have that awareness, and it'll be able to talk to you. You'll be aware that different things are going to act differently. If I get an ore from here, or if I get one from Arizona, or one from New Mexico, they're going to all work a little differently. And I'm going to have to learn to play with it, and learn to feel it, just like the plants are. So we're developing a sensitivity. That's why it's important to do the lab work, because when you're actually touching these compounds, it's putting an energy into you. And that's what the Native Americans talk about. You learn to speak to a rock. The speaking is like a telepathic communication. It's a learning feeling. And so as you touch and hold these things, they're transmitting something to you, and that's the learning. They're teaching you. But if you don't do the lab work, you lose all that experience. You lose that opportunity to feel the energies that are coming off these things. And that's the beauty of it. You know, as you work longer and longer at it, you get better and better, and all of a sudden you can just touch a thing and know what to do with it. You know, it'll kind of speak to you. It'll tell you. It's kind of a mixture of experience and then a direct knowledge. Because we only are experienced. We're a sum total of our experiences. That's all consciousness really is a sum total of a lot of experiences. So we don't have a lot of experiences. We don't have a lot of things to tap off of. We don't have a very good vocabulary. So we should build a vocabulary up by having a lot of experiences, by playing with a lot of things. Then once we just touch something new, it relates to the previous experiences, and that's how we start relating and learning. We're basing at some point of reference. Nobody's seeing this piece of paper the same. They're seeing different shades. We're all assuming that this is some shade of white, but I'm seeing it maybe some little off cream color, and everybody's seeing it differently. Everybody's seeing everything differently. And I'm assuming that everybody's seeing this whole building the same way, but you aren't. Everyone's seeing it totally differently, just based on your experiences and your appreciation. If you're an artist, you'll see more shades than I might. You know, and I might see a different structure, you know, because the more into the science part of it. So we're all making these assumptions that we're all living in the same kind of world, but we aren't. We're all living in our own little worlds, assuming everybody else is living in the same world we are. But it's really a little different to each one of us. That's why we have to learn to play with everything and learn things on our own way. But we can help each other because there's a lot of basic things.
Did you measure out how many degrees arc of that figure eight? You know, just so it has basically, do you recall?
Well, it depends on a compound, you know.
Water.
Well, the water, they said it was 94.7 degrees, the angle. Really here?
Oh,
104.7?
104.5. That's a variable angle, you know.
Yeah, it moves. Yeah, and
And still water collapses down to 101, and if you put magnet on it, it'll go up to 106, and if you put ozone in, it'll go to 109.5.
Right.
That's the highest level it can be in liquid form.
right.
Steam 120.
And so it moves around in the water. So that's one way of measuring the energetics, or the energy levels of it. I've become kind of interested in that colloidal water you're speaking about, how they prepared that.
If I may interject, I was listening to a series on the angles of arc, the arc lights and dealing with angles, and it seems that when they did a angle distribution on this is real short and sweet. They found that Noah's Ark and they did the angles on it. Have you heard of that?
No.
They built if you measure the sunset for all the 52 weeks, it comes out into this is figure eight. It'll come out that way. And I forget how many angles it was, but they built a bolt in Frisco and LA, and they on that configuration. When they took that bolt out to the sea, and in Frisco, the waves can get awesome. The boats just get submerged. Normally, water will cascade over. When they built that bolt on that to go into the sea, the bolt did this, went under and over the waves, and also what happened, everyone that was in that boat had no feeling that they ever went upside down. And there was angle distribution on that. And so, there's one lecture that said you got to pay strict attention to the angle distribution. Whatever out going on in the universe, the same as here. That's why this one fellow, David Suzuki, won the Nobel Prize in genetics, and he's an astronomer.
Mm-hmm. Yeah.
He's on angles.
Interesting. Yes.
What issue is this?
Pardon me?
What issue?
Oh, this is May 1993. Yeah, May 1993. I should have brought copies of it, but I already had about 8 pages, and I told them I was going to only bring about 3 or 4. And these don't copy real well. I have to put them on big 11 by 17 sheets. There's something odd about some of them span 2 pages, you'll see, so you have to put them on large But if there's a big interest, and I could maybe send them to Sue and Russ, and they could copy this stuff and distribute it on their list. And maybe we could stick it in the stone or something like that. Of course, we have to get permission, which they probably will. If not, then we'll just have to alter it. Or just stick it there and hell with it. Now, this is some of the laboratories, the work they're doing. So I find this really fascinating to read this article. They show over here the actual enzyme, between enzyme bacteria structure. They don't really know what to call it because it can't be killed. The higher the pressure, they said they're finding it down at the bottom of the sea at 700 atmospheres, 700 degrees and like 500 atmospheres pressure. I mean, tremendous, tremendous pressures, tremendous temperatures. The hotter you get it, the better it works. And they're finding out they were getting transmutations that was forming like tungsten and different metals. And they did a chromatography separation of some of the products that were coming off it. And they found some of the red ones, and they thought that they'd be iron, but they found some iron, but they found mostly tungsten in there. They found out that these were transmuting the elements. The only byproduct they gave off is hydrogen. And hydrogen, we know, is at the beginning of the periodic chart, so that's the mother of everything. Everything comes out of hydrogen. All our elements came out of hydrogen. So then our water is 2 hydrogens and 1 oxygen. So these are kind of interesting ties, because here's the mother of the universe, and then the oxygen, which is tying it to life force. And it's all in water, the simplest substance. They talk about, the vulgar material where you step on it, and some people will, bitch about it. You have to rain on them, and they want a nice day. And it can be found everywhere. So I started thinking that it's really got to be the simplest compound. They always talk about in magic that if they could really tell you the truth about magic, they're so simple that you'd laugh. So they couldn't tell them to you because they're so basic. So we have to become again like Christ to become again like a child to enter the kingdom of heaven. We have to start thinking very simple. So we got to walk this plane where we know what science is, but we got to become to have that childlike innocence and that simplicity to be able to see the beauty of the most simple things. And that's where it's really at. That childlike simplicity, that beauty, that innocence. We gotta get that back. And that's why we're here, because it's all we have fun and play. I try to introduce always when I worked and stuff. There's joyfulness. Have joy in your work. You could do engineering stuff. So I work as an electrical engineer. We could do the stuff. We could have fun, make everything a joy. And find the good in something. Don't be harboring about the bad thing. And don't be so lazy to go over there, because I could run over there and I get my exercise. I don't have to go to the gym at night time. I've done all the work and you paid me all day long. So that's why I stay like I am. I can buzz around all the time and go, I might as well do my exercise with work and be paid for it. So this is a neat thing. We'll try to get copies of this article because you read about that and you'll see that this is the enzyme. So I believe science is getting so close to it. That's why I don't like to hold anything in. Nothing's a secret for anybody. I want everybody to have everything because I want everybody to do it. Because I think the Earth, it's changing so fast now, and I don't see too many stones floating around. So maybe by the next year or two, we could have some of these things. We need them. We need them to help the planet, help each other. And scientists, if we don't get it, the scientists are going to get it. We don't want them to have it. Those jerks, they gave us a hard time forever. I'm not talking about everybody. I'm talking about certain parts like academia, because they always give me hell. Every time I try doing anything alchemical-wise, you got to just lie your ass off, really, to get anything through, and tell them it's something else. Oh, yeah, it's part of this project, because they are so closed-minded. It's amazing. You find a couple neat ones. Now, I found the only people I could talk to are quantum nuclear physicists. Go to university, you could talk to those guys. Anything goes, because they're so far off into multiple dimensions, and to antimatter, and to time reversal. So, you talk about anything, and they all, know about UFOs, and everyone that I talk to believes in them. You say, yeah, of course, it's possible. I could calculate something on the top, It works out in the math. So these guys are the only cool guys that I found I could really talk to, quantum physicists. So you go to university, you find a guy that really wants to talk to you about alchemy. Everyone that I ran into gets so excited when you bring it up. They usually pull out 4 or 5 books that they have on it. They put them like files called weird stuff and neat stuff, and out of the way stuff. But they're important files, you find out. That's when the other people come in, their bosses come in and go like, oh, what are you doing? I'm just looking in the weird stuff pile. One of my students asked me something. So the enzymes, this is further proof that the water is carrying them, and the silica, or the sand base, with the minerals. So that's the importance of using the raw ore. Now what happened with Marcus, he had the antimony sitting out. He had what to do. He had it in a vent where moisture or air was being pulled through it constantly. So the moisture was going onto the metal. And as it sat there for a number of years, it started accumulating as life force. It started picking up the moisture. It started trying to go back to the ore that it used to be. And that's why you got the good results the first time when you used that old stuff that was sitting in the cardboard box so it can breathe. And then later on when he got the purer stuff, didn't get the same results. The only difference was it was exposed to moisture. They just something.
Picking up some bacteria too.
Yeah, it could be picking bacteria, it could be picking up some of these enzymes. Because these things are all being diffused and being carried through, but it's being carried through by the most simplest of substances, water, the water vapor. Here's a little bit to show us. This is the electromagnetic spectrum shown as light. I'll make sure I go on my notes so I don't miss anything. Visible band. I'm just trying to show you how little we see in part of electron. They're only going from radio to gamma rays here. But you see this little band over here is what we see. We're not seeing a whole lot. Now if you notice, there's infrared region. I have second clue that all the life energy can be measured in what they call the far infrared spectrum. And I'm going to show more proofs of where I find that it's measurable in this area. You notice the infrared region is wider than any region at all. This is our thermal or heat region. Chi or life force or healing force, sometimes felt as heat. It's felt as a thermal energy. And then we see our visible band. We see a little tiny crack, and here is all the infrared region. And then we have ultraviolet, with its real high energies. But there's some interesting things we'll see. This is a big electromagnetic spectrum chart I got from Edmund Scientific, which is number 5 in there. I even have the part number. Edmund has a lot of neat optics and neat little charts and neat little chemistry widgets and fidgets. This is our entire electromagnetic spectrum as far as we can measure it, going all the way down to ELF, 0 hertz frequencies. So you notice in this huge spectrum of life, there's a little crack we see. That's the only thing we can, that's a visible light spectrum. Yes?
There's a man in the world of optics, Dan Winter.
Yes.
Now, you heard of him? Okay, so you know that you can communicate on all this other levels of machine that is made.
Yeah, oh yeah, okay. This is a close-up of the little visible light spectrum we're seeing. And see, it happens to be in the band they call solar radiation. But, and here's the infrared region. Look at this big puppy over here. Far infrared, intermediate.
Where do you think about the light force?
In the far infrared region here. Yeah, far infrared. Here's another different chart showing the energy transitions in the molecules. What's happening to the atoms. At the radio frequencies, this is what they do, what they call nuclear magnetic resonance. They use the radio frequencies to energize it, but it goes to the nucleus. It causes what they call nuclear spin transitions. So the nucleus will start wobbling on its axis. And this amount of wobble, just like a top spin, and it'll start wobbling like this. They'll make it wobble, when they stop it, it relaxes, and it gives off an energy burst, and they can measure that. That's where we get their nuclear magnetic imaging and their magnetic, what do they call it in hospitals, magnetic resonance imaging or something? MRI. Yeah, MRI. They don't like to put the word nuclear in there because people get scared.
What frequency range do they use there? How many microvolts is it done in watts, or like 500 kC, extremely low frequency? What range is that?
10 to the minus something.
10 to the minus 6.
10 to the, that's the amount of energy per mole, 10 to the minus 6 kilocalories, but the frequency is a 10th second meter, 10 to 1 meter to 100 meters.
Say that again?
1 to 100 meters.
1 to 100 meters?
Meters, yeah.
Extremely low, okay.
Yeah. And the power levels depends on the application.
Is it like a pulse? They just have like a 10 millisecond pulse or something?
Yes, and then the newer ones where they have Fourier transform, or a computer analyzes it immediately, they hit it with a pulse and they measure it.
So
They hit it with a pulse.
Extremely low frequency radar is what it is. They use a little different semantics.
Right, yeah, because if we go up to the next range, which is microwave, where radar is at,
Yeah.
10 to the minus 2 meter is length, that's where we get rotational motion, where the molecule starts rotating. The infrared region, we get molecular vibrations, where we're getting everything vibrates. And this is where our infrared spectrometers come in. So this is where the molecule starts vibrating, the entire molecule.
Which book is this thing for which?
This is between I had two books, a physical chemistry book and an organic chemistry book.
Is this on our pass outs or sheets or anything? I didn't have any pass outs. I was curious to see.
No, this isn't. I couldn't copy everything because I have about 200 slides. So
Okay, this is a particular interest to me.
yeah, we could just yeah, we could copy it.
During the break, I was looking for it.
We see we have the ultraviolet vacuum, ultraviolet X-rays, and gamma rays, and we get electronic transitions and ionization over here where things start coming apart. The ionization region is where they're using like the mass spectrometers. Sometimes they'll ionize a compound, they'll break it down to individual ions, and that's how they do a mass spectroscopy. We talked about it in the infrared regions. We're getting the vibration motions, and what they compare it to is like two balls in a spring. And they call them stretching frequencies because the molecules tend to stretch, come back and forth, and that's the vibration energy. They'll stretch and they'll compress. They go back and forth. And here's our water molecule, and it tends to get, there's three modes that molecules can vibrate. They call it symmetric stretching. It'll stretch this way where we can see they both go out at the same time. They have anti-symmetric, where one goes in and one goes out. And they'll have bending where little scissors like this. And that's where we talked about those different energy modes of the water, depending on whether it's steam or whether energy is bound to it. So these are some of the vibrational modes, they call it, that they use to measure things. This is out of a physical chemistry book. This was showing the different stretching and bending. We see we have like an energy field. We have the X, Y, Z, the three-dimensional axis. We saw that in the cube of space. Yeah. And we'll see that into electromagnetics, and we'll see how matter is actually created out of electric field. But here we're seeing the cube again in a different form in the chemistry books. So this is showing what they call Raman spectroscopy, where they hit a molecule usually with a laser, and at a right angle, a light will come out, or an energy will come out. It'll fluoresce or phosphoresce or give some type of energy. It'll come out at a right angle. Well, see, the right angle is really important. The way everything's created out of magnetism, everything goes to right angles at each other. We also notice in a lot of UFO reports, the flying crafts will kind of suddenly go at 90 degrees right angle, because they're working at the energy level, working at pure energy. And the whole universe is based on three right angles. This is a graph of infrared spectroscopy where I've been trying to do some measuring work and measure where the life energies are at. Now the chemists use normally this upper region. This is what I call the different stretching frequencies. Here we'll see a carbon-carbon double bond, and a carbon-oxygen, carbon-nitrogen triple bonds. And this region down here, which is getting to the infrared, this is a higher infrared, they call the fingerprint region. The chemists don't use it, so I go, that's what I want to study. Whatever they don't want to. The fingerprint region, they call it a fingerprint because every chemical, when it's extremely pure, it's just like your fingerprint is, there's a special pattern to it. And it's my belief, and as we go into the farther infrared, that this is really showing the etheric energy field of matter. This is really showing where the pre-matter form is at. It's being held in this region. This is really what you might call the aura, the energy field of a substance. It's magnetic energy that holds it, attracts matter to it. So it's what's called the fingerprint region. It's always perfect. We'll look at some of the fingerprints of compounds. It's pretty simple. It's just a hexane. And we see now we're getting more, I kind of drew a pencil line, where we're getting the fingerprint. See, the chemists can't really interpret it down here. Here's a compound that's more complicated. We get a more complicated fingerprint. Now, they don't take it very far back. They're only going up to what they call 600 wave numbers, which is 1 over the wavelength. I'm going down, trying to go all the way down to 40, getting more into the far infrared. And we can see more examples of different compounds again. And here's our own air, the absorption of air. And we see we get a certain region over here where it's absorbing a lot of energy. And we're seeing down here now where you get into near the infrared, and the farther infrared, it's absorbing a whole lot. If they take it further down, apparently it's absorbing a great deal of energy in the far infrared region. And that's where I believe the etheric energy is being held, the mold. This is kind of a view of the spectrometer that I'm playing with that I have. I got an older one because the newer ones start at the higher wave numbers, because since chemists don't use that stuff anymore, they don't even build it into the equipment, so you have to find an older spectrometer. And where you can push it even further down. I found out the detectors in there will detect a lot further than that. You have to just take a very long time to adjust. Yeah. It's a Beckman IR10. These are the two little cells where you put things in.
You need Tektronix?
No, Beckman.
Beckman?
Yeah, Beckman Instruments. Yeah, they make analytical equipment.
You say mass spectrometer or gas?
No, this is infrared.
You have an AA?
Hmm?
You have an AA?
No, I don't have AA. Yeah.
Got it.
Okay. I like toys.
What make and model and year is this?
Beckman
IR10, Beckman. It's probably about 78. And I got it for like $600. And I had a brand new detector put in, which cost $3,000. Plus, the guy, who was an older man, he had a place called Genie Scientific in Fountain Valley, California, and he rebuilds all his equipment. And he was in the 70s. He wanted to get out of the business. He's trying to turn it over to his kids, but he knew so much that he couldn't really turn it over. Everybody's been doing it, so he's working there 7 days a week still. So I got there on a Friday when he was doing nothing. He sold this to me cheap, and then he gave me like $5,000 worth of cell windows and little things to make your potassium bromide pellets and all kinds of neat stuff. Different gas, holding Windows assemblies. And so I gave him a lot of stuff just for free because he just wanted to get rid of it. Variacs, threw a bunch of Variacs in. He says, anything you want, just take. I'll tell you.
Can you measure any gas with that?
Yeah, as long as you get the gas into there, yeah.
Yeah.
Now my problem is trying to measure water, because all these cell windows that I was given pretty much are salt or potassium bromide. They're all water soluble, because chemists mostly deal with organic chemicals, and they're non-water soluble. So you can't find any. There's only one. They call it rat poison. It's a thallium fluoride, potassium thallium fluoride. KRS5 is the name. It's highly toxic, but that's one that'll is non-soluble in water. I don't have one of those. They're very expensive. The only thing they didn't give me was one of those, and they're about $235 each, and I'll need 4 of them. This is a dual beam, if I want to use a reference. So I found that polyethylene goes way flat into the infrared region. It's good up to about 700. So I can look at the far region with just polyethylene. Matter of fact, I talked to a couple of experts, and he says just take 7-Up plastic container and just cut a couple pieces out and turn it up and put them on there, and I got a pretty much flat spectrum just from polyethylene. Now I see they're making some disposable polyethylene ones, so I'll look into getting those. These are some of the detectors for infrared detectors. And you see the pyroelectric detector covers a wide range for longer wavelengths. And it's also one of the cheaper ones. Some of the more exotic ones are like these indium antimony ones. They'll actually cover more range than that. They have some newer ones, but they have to be cooled in liquid nitrogen. They're real expensive. I saw some demonstrations at a Hughes thing. I'll talk about in a minute. This is the latest CRC Handbook of Chemistry and Physics, 75th edition. It's just coming out now. But what kind of struck my interest is that they had a whole table over here on infrared and far infrared absorption frequency standards. They never included far infrared, so they're starting to pick up there's something going on in the far infrared region. So when they put it in the CRC handbook, they're starting to tap onto some of this stuff. So my physics professor said he's going to try to give me a copy. The school orders a whole bunch. So let's see if he forgets again.
Oh, excuse me, on that polyethylene, you have to be careful. You don't pick up any polyethylene. Because of the fact that the long chain branching in, don't make it so when you have the long chain branching, it will come out here, or out here, or out here. So you have all those variables there. You have 100 variables. They can really stick way out here, too.
All right.
So if you just call in someone in the polyethylene business and tell me you want something that's got a far end long chain branching,
Yeah.
which grade they can get for you.
Yeah, Kodak, like I said, I think Kodak or 3M is making something. I just saw an ad in the ACS journal. They're making disposable polyethylene ones for measuring down here. So that if they're cheap enough, they'll probably be cheap. That'll probably be the best way to go because they made them for infrared. So that's probably the best way to go. I just found that in just a recent magazine last week I was reading. This is the way a spectrometer works. To give you an idea how some of this equipment works, all I simply do is have a glowing wire source, something that's hot, and they bounce it off some mirrors. And they usually have what they call a reference cell, and they have your sample, whatever you want to measure inside there. So the beams, both beams are going through it, so they're checking out the difference between them. They have a little rotating mirror on a motor spinning around, usually about 10 to 100 hertz, and it's chopping it. And it goes into what they call a monochromator, means one color. Okay, so what it is basically it's like a prism. They use a diffraction grating now, which is like your holograph screen. It's like a prism. You put a beam through it and it breaks up the spectrum of the colors, and this little thing turns. And there's a little slot there, so it only sees one color at a time. The prism keeps turning, and you catch one little color out of it. So it comes through the slot, and it goes to a little detector. The detector says, okay, what's the energy level here? It generates a voltage. It's like a photocell. So that's all these spectrometers are. All I do is generate a reference and put them through your sample and put it through something that breaks the light beams up and have a simple detector. So now you know how all analysis equipment works. Except mass spec, they do it by a magnetic field. But so you can understand a little bit about the way your spectrometers work and some of your analysis stuff. They just use beams. Now they have ones for the visible range. This is simply be replaced by, they use actually a car light bulb, a backlight, and some of the middle class models that they found. They made the tungsten bulbs for your car lamps, your backlights of your car, to be very wide spectrum, so they can be seen very well under all conditions. So spectrometers actually use those bulbs because they're highly accurate. Except when you get to the high end. Yes?
So are you saying that when this machine does this, that it uses the light sensitivity of the large spectrum area of the infrared in order to be able to identify the magnetic fields of the elements?
The energy field, this is the range where matter starts vibrating. And when it vibrates, it'll trap some of the energy when it vibrates too hard, so that it'll show it as an absorption. You know, it'll absorb the light energy because the matter has absorbed it at that frequency. You trapped it in because it's resonating, it's vibrating.
This resonance vibrating is magnetic field.
It's the field that's holding the thing together, it's really an electrostatic field.
Just like inside the MRI, when you're spinning the things there, they get the temporal effect.
Right, yeah. But in an MRI, they're making a nucleus wobble. They're hitting with a pulse, it wobbles, and then when it stops wobbling, it gives off an energy. You know, just like they hit something, then the next one billiard ball transfers to the next billiard ball. So the transfer actually comes back out of it. We'll show a chart later on of how energy is pumped into something and it raises it to a higher level. That's where the quantum physics came out. They found out that energy takes discrete jumps. That's what quantum means. It means a little bundle of energy, a little packet of energy. So these quantum leaps they talk about. That's where quantum physics came out. It came out about Max Planck, when they were trying to measure the radiation of sources like this. They call them black body radiation. And they had them in a little box with a pinhole, and the energy was supposed to come out equal according to the classical physics mechanics, as they varied the temperature, they found out that it wasn't. It was coming out in discrete energy levels, no matter what the temperature was. So that's where Max Planck started coming up with the quantum of physics, and they have a thing called Planck's constant. So we find out the energy tends to jump in steps, and there usually tend to be a whole number of integers. So we're finding out that stuff is pretty simple. They've also found out between the two fields, quantum physics wasn't talked about for a long time. They called it quantum mechanics. In about the 60s, they started talking more about it as physics, because they weren't really accepted real well, because they broke all the classical Newtonian methods. I have believed a lot of these people like Newton and stuff, they were very spiritually advanced people who came at a time and gave us what we could handle at the time. So, when they say someone's theory might not be correct, that might be okay. Well, it might be correct for the time, because that's all we could handle at that time. We couldn't understand anything more. When you find out the true life stories about some of these people like Newton invented calculus, he was in his 20s, 24 or something, you find out these people, Newton was really an alchemist too. We'll find some of the alchemical writings of Newton, and he wrote several books, and he was always looking for the mercury and looking for transmutation and substances like that. We found some of the work he did on antimony and the star Regulus. So as I started studying the lives of some of these physicists and stuff, you find out that they were very spiritual people. So they must have had a very tough time, even people like Einstein and David Bohm, one who died in '92 recently. He was working on some of the atomic bomb projects and wouldn't testify on un-American activities, so they threw him out of the country and stripped his citizenship. But he had a real strong belief system, and then he started writing a lot of works on mysticism and spiritual stuff. And he came up with a series of proving, that we all come from one force in the universe. He's actually be able to prove some of these things, and so some of these things are coming out. And you never learned that stuff in the school. You'll find it in the other little books. You find these people were very, very powerful mystics, and were very beautiful, wonderful people. When you learn the cold mathematics at school, it's real hard, but to find that these people were nothing like what they're made out to be in the textbooks. Anybody can get that far into nature, has to be connected with it a lot, and they have to feel the beauty of it. So they're alchemists in their own right. This is a book where I've kind of got an idea of what was happening with the far infrared. This is a cosmic pulse of life by this Trevor James Constable, a revolutionary biological power behind UFOs and other things. He was in the military doing a lot of topographical maps and doing stuff in the infrared region, and he started picking up all these strange objects. We set about the investigation later on. And it turns out these things are in the infrared and the far infrared. They was using certain infrared filters. And he was getting these strange, we call them plasmatic fauna, invisible to normal human sight, Mount Wilson, California. But he's finding these things all over the place. They show up as like these protoplasmic blobs. And as he says anybody can photograph these things. You just get a number, I think it's an 87C filter in some infrared film. And you'll be able to pick up some of these life forces. Now he found he would go on a mountain and do like meditation or Tai Chi or some other exercise, and he was attracting these things too, but he's also attracting elemental forces and other kind of like neat little spirit forces, and they were photographable. So as he was doing meditative exercises, these life forces were being attracted to him, and they're actually being able to be photographed.
Portae 600 film?
He was using a 35 millimeter and used infrared film, but some of these pictures were showing up just on black and white film. Here they're using Praktika FX2, F19, 1000. They use high-speed infrared film. But I've done some of the stuff I've gotten on black and white film to work out, and just color film sometimes, but the infrared film's got the wider range. But the even black and white film respond way far down with the proper filter into the infrared region. Matter of fact, he says if you go out of the plane, yes, Art? Yeah, it's on.
Trevor James Constable.
Right, okay.
Yeah, Borderland Sciences carries it. Reference number 6. The cosmic pulse of life. But it's just, if you just take a camera and put the 87C filter and go on any plane flight and start shooting out the window, you pick up at least 1 or 2 UFOs. It seems to follow every plane. This is more of these biological type plasmas at night. There's some in Genoa, Italy. And at nighttime, see, these things show up at nighttime. When we get later on, I want to talk about some stuff about radionics and psychotronics and about some equipment that I built. Some of this equipment that actually attracts this matter, and I found that it came at nighttime, which is why a lot of times at night, it's a harmless, pre-protoplasmic type of energy that I found. And that's why it comes in the dew water, and it's being at the upper atmosphere, it's trapped in the rainwater. Constable wrote the Air Force with all these pictures and sent them the stuff, and they acknowledged that they've been measuring this stuff since the 30s, and they just called it space protoplasm. And they found that it came down at nighttime, and it rose back up to the upper troposphere at nighttime. So just, they've been measuring this stuff, and we're quite aware of it, because it interfered with their instruments. And NASA is measuring it all the time with their space labs out there, with the infrared detectors. So, we're getting more and more clues of where this life force is and how it's binding to the water.
It's increasing, especially increasing in amounts that are coming up.
Yeah, this is, he took a photograph, Air Force Base near Victorville, California. Here's the jet trying to intercept the UFO. What the UFOs do is they go, we saw the electromagnetic spectrum. They know more about energy and energetics and electromagnetics. What they simply do is they shift the energy, the entire structure, into the far infrared region, which isn't visible to our eyes. They just go into a range we can't see, that's all. But the radar picks it up. That's why the radar, you'll see a lot of planes, and they'll come out looking for something, and they can't see it, and they'll pass right through it because they shifted their molecular vibrations to a range we just can't see. And here's a photograph where it's picking it up. You can notice a lot of the protoplasm stuff that seems to be around it too. One more back. Preston Nichols, who wrote that Montauk project, I talked to Preston quite often, but he picked up some infrared camera equipment that he got out of one of these strange things. Synchronicity always works with them, where he got called with some special deal was going on. They were doing some military research stuff. Yeah, and he bought for $75 about $150,000 of these amplifiers, optical amplifiers, that measured far infrared, and the ultraviolet region. And managed to get the stuff working together again. And he's able to vote it. He says, you just hook it up, and he's going to be making some videotapes, and you can just photograph UFOs all night long, he says. And you've been up to Montauk, and you see the energy coming off the antennas. Yes?
What was that correlation on that? He was using, put up on the top of his house at the former. If you operate at a certain wavelength on that, which was stored in the memory bank and had a lot to do with the many other aspects of life force. That you put on his house.
That's a Delta T antenna.
Okay. And that restored total memory.
Yeah, it brought his memory back. We'll get into some of the Montauk stuff in the Delta T, because it goes into the octahedron, which ties back to Kevin's cube. He had the octahedron all over there, and it also ties to the Qabalah and the upper triad I found. We'll talk about that when we get into the electromagnetic portion. But Preston was doing, actually has the cameras, just like you just sit and watch them all day long now. He'll be coming out sometimes with videotapes. You just sit there and record them. UFOs flying around all the time. And you can see all this protoplasmic stuff too, because I told him my effects when I started seeing these things. This is why we see things at night too. I found out that this energy is attracted to your thoughts and actually build a thought form. And I was able to manipulate it and pull it so strong that I could create a thought form and it almost would take on a life of itself. It could touch you. Yes?
You can also see it without the camera. You use that 50-50 alignment on your cross vision that they call it, I forget the proper term. But if you cross your eyes and then you receive them back, and they're starting to sell it back in the stores now, stereographic vision.
Right.
You apply that and just practice a few minutes every day, and then at nighttime you can just apply that vision, and then you'll see it without cameras.
Yeah, that's the other thing that I found about the trying to see the aura, the infrared. Since infrared's a longer wavelength, Here's our eye. The infrared's going to focus back here. Because it's longer, so it's further back. Now the brain tends to ignore things that are blurry, that's not a clear signal. So when you see something clear, that's focusing back here, when we're looking with normal vision, we see it. That's why we're told to look beyond it. If you look beyond something, you're bringing this, you're shifting it up. So now we're blurring the normal. So now the brain starts focusing on this farther region, because we just, by looking beyond something, we move this whole spectrum up, and now it's focusing back here. And the far infrared and the infrared region is focusing in the back of our eye. So by looking beyond, blurring our normal vision, the brain starts focusing on this other signal, because that's all it has. And that's how you can start getting that auric vision. You can start seeing the energies, and it's tied into that thing you're talking about too.
The Japanese have found a way now to do those stereographic stills. They found a way to do it on film, so you get 3D without having to use glasses or anything.
Oh, really?
Yeah, should be coming out maybe 2 years.
Great. Yeah, Japanese are doing a lot of interesting stuff. They have these ceramic beads. They purify water. They just put water through it, and it has a spin to it. Chemistry talks about electron flow now. And I was kind of shocked when I went back, because I hadn't taken chemistry for a long time, since 1969. I went back, I found they're talking all Schrodinger wave equations, and everything is electron flow. Which is kind of neat, though, because now they're really finding out how matter is really working. So these are just a couple different configurations. You see some of the different bondings. This isn't real easy to see. I realized that when I was watching it last night, but they have things like the oxygen molecule, and they'll see the lone pairs on it. They're showing the way it's being attracted to the hydrogen, and this bond is breaking, being attracted there. Everything now in chemistry is marked by electron flow, where the electrons attract, repel, and pull the charges apart. Well, it's not the old simple equations where, copper plus nitric acid gives you copper nitrate. They want you to do everything with this electron flow type charge. To the water. Now we're getting some more of the alchemy stuff, rainwater distillation. We saw it in stone. Somebody came up with this thing last issue, and I've had this thing for about a year. I was testing it. I go, great, somebody else came up with it too. Those are what I use for the rainwater. I found by doing the alchemy, I started going back to the way the alchemists did it. When I was first doing it, I was using a modern laboratory equipment. I wasn't getting quite the results, and I started using a retort then in the last couple, 2, 3, 4 years. And I found out, because I keep things at a lower temperature, there's that flow, that femininity. And we know that molecules tend to get that Brownian motion, they get that curling spin like this. And so the retort, fits it just perfectly. It has that nice flow. Might as well not fill it up. So things tend to move in this kind of direction anyway. They tend to curl. And the retards are perfect at that. We can almost see, if we have two of these, we have the yin-yang symbol. So we have the masculine and feminine over there. This is really more the feminine part. So everything tends to flow and just go over gently. So with very low temperature, we can get things to come over. The flying cat. So, I don't know where it went. Anyway. Temporary. So I came up with this apparatus because I wanted the rainwater distillation very, very slow, since I was finding that I could find a lot of the energies in it. And I was trying to do everything gentle, because I was finding I was getting a lot better results by doing things very slow and very gentle. I think part of it was a change of my mind state too. Our Father Al-Baruch used to always, you'd ask him something, he'd say, well, in your way of thinking, yes. And it puzzled me for many, many years. What was he talking about in your way of thinking, yes? And I think what I came up with that, he was trying to tell you that as you think, that's the way it's going to be. And if you think that way, yeah, that's the kind of results you're going to get. But I also found out that if you don't follow what nature wants to operate, your operation is not going to come out right. You can try to force it into something unnatural, like some of the chemists and physicists try forcing unnatural configurations, and they blow up, when they release the energy on it. So as you think, it's going to cause a reaction to occur and change. So possibly as my thinking changed, I started coming up with the ways that the alchemists did it, and I'm getting better reactions. These things will distill over at very low temperatures. There wasn't a little seam here at first, and I was getting very low yield. So then I had the glass blower pull a little bubble here to catch it, a little shell. So it caught more of the water that went down than came down. I did all my rainwater distillation using this apparatus, doing it real slow. I'd sweat over about a quart a week. So I was taking my time, and I took a number of gallons, so it took a long time to get a good amount of water. But I found by doing it very slowly and gently, yes.
I didn't mean to interrupt you. There are different methods. Junius gives you one way, Alchemy gives you another. Which way did you go?
Oh, while talking about a separation, I was just distilling the water.
Oh.
I wasn't making like it.
Distillation.
Yeah, I just
very slow.
Yeah, very slow distillation. I was just trying to get the rainwater fresh, because I found when it putrefies, you get a different product. You let it sit for a long time. When you want to make the archaeus, you get a different product. When you get it fresh, you have a different type of energy. When it putrefies, you have a fermentation, you have a separation of the elements. I wanted everything there because I wanted it to be a dissolvent. You know, just a general purpose dissolvent. And just see what I was going to get out of it.
Okay, one more question. Was there any residue left?
Yes, there was a residue left. A gur, a powder. I poured it out in a dish and let it dry, and I got that brownish powder gur. This was even out of L.A.
Did you do analysis on the dirt as well as actual comment?
No, I haven't. I haven't yet.
What was the question?
Did I do an analysis on the gur? That's just with some of the stuff taken off it. You notice I was using a little fan back here. I'm using any water cooling. I just put one of these little 3x3 inch fans. Doesn't put much velocity, and that's my only cooling. So I don't have any water problems. You know, having water flow, and that cools it sufficiently, since I'm just sweating it. You know, what happens? You get a nice. The vapors, they have to make it up here, be volatile enough to make it up here. And I found there's something going on. There's something going on with expansion, going to contraction, going back to expansion, going back to contraction, going to expansion. There's something about that expanding, the yin and yang, that in and out. The expansion, contraction. Yes?
So we're talking about some of the aspects of spiral effect, and that nature follows the releasing of those spirits.
Right.
The divine area. I wonder if you ever tried, when you have that spiral effect, you have an actual spiral coming off of that top section and follow that natural curve down. I wonder what would happen.
I don't know. Be interesting thing to try.
Yeah.
Yeah. There's a lot of stuff to be done with spiraling water too. We have a lot of these things called some of these formworks, a place I think in California even, where they're putting water on a spin. They're spinning it down these long sloughs, and they're finding by putting a spin. This is based on some of the work of Victor Schomburger, who did a lot of the research. He was an Austrian. And they're finding they can get rid of bacteria and contamination of water just by spinning the water and giving it a spin, and it purifies itself, and the sludge collects on the bottom, and they have a nice clean water over here left. So they got a couple of places. Apparently there's the big ones type of Pasadena and a couple other places where they're purifying water just by spinning it.
It's interesting to know too that in Sweden they use that technology to keep the pipes from leaking.
A mineral deposit, aren't they?
Double spin keeps the insulation building up in the pipes. It's not just chemical.
Mm-hmm. Yeah, they're doing some stuff like that with magnets too. One thing I know is interesting about this distilled rainwater is that it's very volatile. That equipment previously back here, when I would take it apart, and I just put the head here on the side for a while, but the next day it would be completely dry. Well, just everything was gone out of it. And then I noticed when I had rainwater in bottles, and these are different sizes, but I had the same size bottles, and I had them in the same place, the rainwater bottle would evaporate. So I had to put some little seal on to keep it really, really tight. This stuff was very, very volatile. I'd have two same bottles. I had two bottles that were similar with just regular distilled water that I bought, and distilled rainwater, and this thing would evaporate in a couple months. Yes?
You did this just for the factory, but you're not also allowed to put some sunlight, right? Rainwater?
Yeah. Yeah, I just took it outside to photograph it. Yes?
What percentage of the water typically did you distill over the flux that's crushing?
I distill it down to about 90% distilled over. Yeah. So I got just started getting thicker and there wasn't too much in the bottom left.
One more stupid question.
Nothing stupid.
Have you tried evaporation of rainwater without distillation?
Oh, it's like a solar evaporator?
It's slower than regular water. But this is speeded up considerably by just the slow distillation.
Mm-hmm. Yes.
Now, you said you were using low temperature of about what?
The water wasn't boiling. I had it in the heating mill. I just kept raising the variac. It was about I stuck a thermocouple probe in there and measured it. I have to try to remember now. Water boils at 100 C. I think it was about 70 C. 70 to 75 C. Down in the heating mantle. And that's where I got to the point where the vapors would just rise enough and start condensing slowly. So I just turned it up, slowly. I think it was about 20 volts AC to that. I think that's a 250 watt heating mantle. That was a 2 or 3 liter flask. About a 3 liter flask. That was the glass blower just took one and formed it for me. I pulled that stuff out of Beach of Valentine. I was basically trying to get a helmet type thing. So that was the rainwater. That was the rainwater I used, and I'll show you the things that I started using it. I did a archaea separation, but I did that in a retard. Now I separated about 4 liters. It took me about 7-8 months. I did it very, very slowly, and I sweat it over divided portions. So I have about 4 liters of archaeas. I have them separated. I can put them together different ways. I'm talking about some of the salts I was forming now with this water, this new rainwater. I was trying to. My wife had her blood level went real low, her iron level. When she had a blood test, it's like anemic level. So they tried to put her on the ferrous sulfate pills, which she couldn't tolerate, and got her real sick and didn't do anything for her. So I remember Albertus made this living iron sulfate, ferrous sulfate, that he talked about. And so I had to look up the process and kind of remember what he told me. And then Carl Stahl did this too, another one of my teachers. So basically I took pyrites, the fool's gold. I had these little bags that I picked up somewhere in Minneapolis with real small little chunks of the fool's gold, real pure. It wasn't mixed with anything else. They were selling it at one of these places, like for tourists. So I had this bunch of these little, they're like $1 a little bag, couple ounces. And I just kind of pull out the nice pretty pieces and I ground it up. FES, iron sulfide. So because I'm back to the point where I want to take everything back from New York. And what I did is I poured first normal distilled water on it. I just added some distilled water. Now, I put it in the baking dish, so we get like a paste. I made a little, you see the water level just kind of sits up there now. I made some screen. I took some screening that you can buy at the hardware store, a nylon screening, and put 2 layers on it, and I have some tape to hold it, because I wanted to get exposed to some air. And I was trying to form an iron sulfate, ferrous sulfate. I let it sit for a couple weeks. Now I figured out what was going on there. So I write you out the formula. Basically we have an FES, iron sulfide, plus H2O, plus you have to let it breathe air. So put the lone pairs on. Oxygen. And we want to get ferrous sulfate. The ferrous sulfate is a heptahydrate, 7 parts of water joins to it. So, to get the equations to balance, I have to actually use 7 parts of water plus 2 parts oxygen with the lone pairs and the chi. And with this we'll get iron sulfate, FeSO4. It's a ferrous dot 7H2O. This is the way it forms. So I was just kind of curious of what was the math behind it. So we see we're adding, the water basically just becomes water of hydration, but to crystallize, we're good, but we're pulling 2 oxygen molecules, 2 O2s, and that's forming the FeSO4, chemical-wise. But this is a living one, because we pull it out of the air, out of the moisture. It's like the Marcus had his antimony sitting in the moisture, the air vapors. All I do is after I let it sit for about 2 or 3 weeks in a cool place, not very warm, I filtered it and I got a green liquid, a pale green liquid. And then I evaporated that, I distilled it over in the retort, and then I started pouring it back on, distill it back on, and I get a stronger tincture every time. So I was getting a multiplication effect. So I had the belief, okay, we have the ores and there's something living in them. And you put the water back on and you distill it off, and you pour it back on, and I started pulling off a better ferrous sulfate tincture every time. So then I says, this is how I distill it over. I just let it sweat over, and then as it got concentrated, I let it cool and the crystals will come out, the green crystals. So I started giving that to my wife, and about 25 milligrams a day, and our blood iron level started going up. But then I said, I wonder what this rainwater is going to do. So I took rainwater, I substituted, I poured rainwater, I let it dry out first, and I just poured some of that distilled rainwater that I sweated over very slowly. And then I found it was very volatile, so I had a little flap over so it can breathe some, but I had to cover it up because that rainwater was so volatile that in 3 or 4 days it was all gone. It just left. So I had to partially cover it to trap it. Now what happened is as I let it sit there and I saw no color changes, and then I started opening up more and more, and I had to pour more rainwater in. I wasn't seeing anything. There was nothing appearing. I wasn't getting the green color. And what I did is, and I just said, okay, I'm going to distill it anyway. Maybe bring it back to life. So as I distilled it, and I was distilling in the retort, I noticed there was something, little crystals forming. And I let the thing cool, and it shot into these beautiful white crystals. And I got a salt of iron. I put on here a vitriol of iron, but I don't really think it's a vitriol. It's beautiful white crystals. They're needles. I took these under a microscope. They're, you heat these things up, we'll pass them around, you can look at them. If you heat them up, they don't. I thought maybe I was just picking up sulfur, but if it was sulfur, it immediately flamed up and went volatile. They were glowing red and they weren't breaking down. But yet if you taste them, they have a taste of iron. Now my wife's iron level went up to about, from a 10 to about a 60, 70. And then I started giving her about 2 milligrams, 1/10 to 2 milligrams of this, very, very minute amounts. Because I was tasting like, it's not hurting me. And then within a week, her level shot up to 170. Went extremely high from 1 to 2 milligrams of the salt of iron. Now, we always talked about the salts of the metals, and I always wondered, what are these salts of these metals? You know, that always seems to be the problem. How do we find salts of metals? But I think that's why Albertus was showing us the plant works so much. You leach them out the same way, but you have to use a living water, or an activated water. So apparently when I put the rainwater on this, it pulled out a different type of salt than just plain distilled water did. Instead of getting the ferrous sulfate, now it pull out the salt of the metal. I'm going to try that sometime, get an analysis of this, but I say if you taste it, you'll taste some iron on there. You can heat it up to a real high temperature and it doesn't break down. So it's not iron sulfate. And there's none of the compounds I looked in the chemistry book that it tends to match. There's not any ferrous compounds that are white like that, except a ferrous hydroxide.
Did you do any of these experiments with thunderstorm water?
That's what I used. I used thunderstorm water. I collected it from a thunderstorm. Yeah.
I used it for paints,
For what?
extracting colors from metals for paints.
Oh, for paints? Oh yeah, you're trying to do that color thing. Yes. So apparently this is one of the ways we can get some of the salts of the metals out, just by the plain water, we can leach them out. But the water has to be an activated or really alive water. When I add a little bit of dew water in there, I got stronger results. The dew water seems to be the rainwater concentrated much more. Yes?
Going back to the lightning storm water, and the oxidation caused by the ozone, which is generated through arcing the electrical discharge.
Right.
So therefore, that's cleaning out all the other particle matter
Right.
in the atmosphere. So for a basis of a laboratory approach, and you have a pristine water to do your experiments with in manufacturing.
Right. There's also doing something to the nitrogen too.
Okay.
Splitting the nitrogen apart.
All atmospheric water has hydrogen peroxide.
Yeah, there's hydrogen peroxide in it too, right.
The interesting thing you just mentioned, you started the project with the Alchemy, and I remember going back, something else happened to my wife, and we got started then on all these salts of plants, and finding out that, ferric salt and various other plants that have, every individual type of salt, and then found out that for every single person born under a specific sign, that they with a certain type of salt.
Yeah, like the biological.
Lacking in that salt, then also everything breaks down. So that was an interesting analogy that self-discovery during that fashion.
Yeah, yeah. So I was kind of surprised at the small amount of the amount of salt that you have to take to get a reaction, to get a chemical reaction, biochemical reaction. Albert said that the ferrous sulfate was a living sulfate, and that you have to just use a very small amount because the body absorbs. If you take the regular ferrous sulfate, they give you like a half a gram of it, and you excrete it, and it comes out, in the bowel movement. It's just black. Yes.
You say you don't know what the white crystal is?
No, it's a salt of iron. But I think it's an alchemical salt of iron. I'm going to use it more. I'm going to try to analyze it. I can't. It's real hard to break down, but it seems to be absorbed by the body really in small amounts. Yes.
What method you use to collect the rainwater?
I just collected it from a thunderstorm.
No, I'm sorry, the dew.
The dew water?
Yeah, the dew water.
I used potassium carbonate, which is interesting because potassium carbonate is K2CO3. So we have 3 oxygens, but it looks like that. So we got 3 oxygen molecules sticking out here with all these lone pairs, just waiting to grab energy. So that's, I thought that was an interesting, when I drew the composition, what it actually looks like molecular-wise. We got 3 oxygens. One's got a double bond, so it's sticking way out there. These are the things that are attracting. This is my theory that it's the oxygen that's pulling it in. So potassium carbonate has a very strong affinity for that life force. So it's pulling it in and adding it to the water. I did find that the dew water, when I did experiments, I don't have as much dew water as I did the rainwater, but sometimes I just add a little bit, like for every liter, add about 100 milliliters of the dew water, and I'd activate the rainwater even more. It's like you're really giving it a kick. So I added a little bit of dew water to rainwater, and it got a lot stronger effect. Here's a process where I started working on sea salt. I wanted to get I started picking up the relevance of chlorides, the importance of chlorides, and the sea salt. And it was also what Jean was talking about last year, so he triggered off something else that was going on in my mind. So what I did is I went out on a boogie board, Pacific Ocean, and I collected 18 gallons of Pacific Ocean salt water. I wanted to get as far out as I could, and I bring them back. And then I took them home and I filtered it. I just threw a bunch of filter papers. So I set up a big bucket here, and you see we have a little hose. I just have a trickle as a siphon, because there was some sand in it. You pick up some sand. So I was just filling up the sand, trying to get the real pure ocean water. And then I put it in a bunch of these Pyrex baking dishes. My favorite things are only $4 for 8x8. Were evaporating just as expensive as hell. I had a bunch of electric skillets full of sand, white sand, and just set it at a real low temperature. And I had a big fan blowing it, because I was doing this in the summertime, and I was trying to sweat the water off, so I keep all the life force that was in it trapped into the salt crystals, because when the crystals form, they lock energies in. I'll make sure I didn't miss anything. So as you notice, because minerals are starting to rise to the top. And then as I got done, I evaporated 1 gallon, yielded me 150 grams of salt crystals. So that was the yield I got out of the Pacific Ocean salt water. So I figured I wanted to get it live, even though they say there might be some pollution in the water. There's nothing else you can do is use what we have. So we got to do the best we can. So this is closer form of the crystals that they formed. You notice they're not perfectly clear like the nice salts you buy at the stores and stuff, because there's other minerals in there. I find out there's a lot of magnesium, there's sulfur, there's phosphorus. And you do some analysis and you find out there's hundreds of trace elements, several hundred trace elements in it. As I'm saying, everything, that balance of the way the salt water in the ocean is important. I was watching that tape, The Miracle of Life by Nova. And they showed, in the woman, the egg coming out, and then it gets surrounded by a fluid, has exact composition as the ocean. It's the salt water, and the amniotic fluid were in that sac. We're floating around the ocean. We come up with little tadpoles. But the ocean and the salt water is very important. What really triggered off some of the salt stuff was when I was traveling, I had like a dream flash of the importance of chlorine and salt. And it said, all of a sudden I realized, what is our planet covered with? 80% salt water. Why is it all there? It's not there for any stupid reason. It has to be the end product, or there's an importance for it. And then all of a sudden I realized, it said, what's in your stomach? Hydrochloric acid, chloride radical, again. So we have salt, NaCl. In our stomachs, HCl. We know that in the water there's those enzymes floating around in it. Now, in our digestive process, we have to chew up our food, so we have the enzymes from the saliva. Then they have to go into the stomach. They'll mix with the HCl. HCl is about 1 molar concentration. It's a pretty strong concentration of hydrochloric acid. So the food has to go into a chloride form. It has to be attacked by the hydrochloric acid. It'll break it down. But that chloride radical has to be there. If we're mixing the chloride, we've got to take betaine hydrochloride or some other chloride substitute, because we won't be able to digest foods. But also, what happens when these things go into our stomach? They're not going to digest, they transmute. We're getting transmutation in our bodies. We're becoming blood cells, becoming fingernails, becoming hairs. So we have 2 things that have to be there, enzymes and a chloride radical. The oceans, the world's covered with sodium chloride. When I was traveling around, I noticed the mining regions in Nevada and different parts of the country where they have precious metals. I'd pull a car over, and I'd look at the ground, and it was whitish, and I'd lick it, salt. So where all the precious metals were growing.
Probably phosphates.
There's phosphates, but there's a lot of sodium chlorides, too. They have Action Mining, which is like in the very bottom of the list. They have some kind of electronic device, Action Mining number 16. They also sell chemicals, because chemicals are getting harder to get, and graphite crucibles. They found that they have a little thing that basically just measures ionization potential. So they're finding ways to get probes in the ground, and when it becomes very highly ionized, where there's a lot of salt, that's where a lot of the precious minerals are at. So that's another tricky way.
Going back to counting your saliva and your digesters and the enzymes that are in your saliva.
Mm-hmm.
Then across research that we're doing on time, found out that all the human saliva contains exactly the same saliva that all the poisonous snakes have, but they have a very concentration. Same enzymes, digesters also have a lower concentration.
Oh, they're just a higher concentration?
Yeah.
Yeah, so they can break things down better. So these were kind of things that were kind of tipping me off that the salt is very important. And they also talked about some of the alchemical books about the mercury being, clinging to the salt, and the water having the niter in it. So between the hydrochloric and the nitric, or the niter, and your chloride radical, I realized there was something real important going on. Also, when you make Kirkham's menstruum, what do? Take ammonium chloride. We have to sublimate it a couple times to open up the body, and it turns yellow when you sublimate the ammonium chloride from white. And it's kind of weird because when chemists do it, they always get a pure white compound. When I would do it, I get a yellowish compound, and it turns very gold. Now, Kirkham's menstruum was important because it made alcohol was able to pull tinctures out of metals. So what are we doing? We have something from the animal kingdom, the ammonia radical, the basis of our amino acids that our bodies are built of. We have the chloride from our metallic kingdom. So we're having something that's in between from the plant kingdom, something that's part animal, that's part metal. Now this sharpens the alcohol. And you pour it over this, you pull out a tincture of the ammonium chloride, you let it digest, and you distill it off, and you pour it back on and distill it off 2 or 3 times, and the alcohol becomes very sharp. And you taste it. And apparently, some of the chloride must be transferring over into it. And that's what's attacking the metal, getting to the metal. Then it'll open up the metals. But this is another clue that the chloride radical is real important.
Well, actually, your sal ammoniac mixture of chloride and carbonate.
Yeah, ammonium carbonate too.
So what are you really getting there?
Well, that's what they call hartshorn.
Yeah.
The salt of hartshorn, yeah. The ammonium carbonate will just break up into ammonia gas and carbon dioxide when you heat it, I found.
Yeah, you're getting all the importance of chlorine. Maybe your carbonate plays in there.
It'll bubble out of there, but I used a purer form of ammonium chloride where I purified it. So I just have pure ammonium chloride. Yeah, it seemed to work. Yeah, it pulls tinctures out of the metals real well.
Sure.
Yes. We're running out of time. What are we running to about 11:30? I got 11:23. Okay. Okay. I'll get into. I don't know what time to get into the sea salt. We might touch that in the afternoon. Spirit. What I did is I took the salt and I wanted to make it more alive. So I made a mixture of 60% Pacific Ocean salt. I evaporated. Pacific Ocean. When I was driving by Salt Lake City, I saw the big salt flats. I figured, that was another key for Alberta's kind of taught things symbolically. As I was driving by there one time, I saw the big salt flats, and I realized we're up at a high altitude. He was telling us salt, sodium chloride, and the ultraviolet rays are very important for transmutation and changes, and that's the way a lot of matter is created. So I picked up some of the salt from Salt Lake City. I saw people were evaporating it. These proportions might not even be important, just something that I did. I'm just telling you what I did, so you have it for your records. I used 5% of that Celtic gray that they get from the French, that French salt that McLeod told us about and that Russ had. And I used 2.5% of the flowers of the sea and about 2.5% of the best stuff the health food store had, which is pretty much a white crystal, and I found after reading all that stuff from the salt, from that Grain and Salt Society, that it's been stripped 8 times anyway, and the health food stores get it. So what I was trying to do is I said, okay, there's enzymes inside the salt. I want to have a nice mixture of all these things, and I put them into distilled rainwater. The rainwater I distilled, I dissolved it in there. And I put them in a sand bath for about 2 months, and I let them putrefy. I said, let these enzymes, let these puppies grow, let it become really alive. So then I evaporated it down, and then I did it a second time. I redissolved it a second time only. Let it digest again, and then I evaporated it down fully, and I got these real nice crystals of sea salt from rainwater. You pass these around and look at them. Do you think I should continue or go on, or wait into the spirit? I want to talk about how I made the spirit, but I'm going to have to draw a lot of pictures, so we might have to do that after the lunchtime. And I'm going to show you some of the work I've done with the spirit of sea salt. I was trying to get a living hydrochloric acid. because I felt this would be a nice, interesting key, and I wanted to do some experiments with it, so I started forming metal salts out of this living hydrochloric acid. This is a process of what I use, and we'll probably after lunch, because it's probably going to take at least 10 or 15 minutes to get into that. We'll talk about how I made a spirit of sea salt. It's a pretty simple thing to do, because they're making the butter of antimony, John and their crew, but they're doing it by, I thought, a kind of a hard process, and it'll tend to plug up, and the thing would block up a lot, and they're getting chlorine gas coming out of it. And I came up with a simple way of bubbling it into water and getting a living HCl that forms different compounds. That I got totally different results using this living hydrochloric acid than I did if I used reagent grade chemical hydrochloric acid. I got very volatile compounds that crystallize and are sublimating extremely low temperatures. And so we'll get into that more and talk about that then after the lunch break then. Okay? All right.